All right, so hello everyone. This is the part two or the continuation of our meeting last week. So now we're going to be studying module 3, which is again about describing data. So before we start our lesson, I'll remind you once again to fill in your attendance on Teams chat. So first one, population mean. So there are data that blah, 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 blah. And population mean is the sum of all the values in the population divided by a number of values in the population. So for example, say there's a housing complex, okay? Let's say it's complex XY, right? So this complex XY has 500 inhabitants. And for example, 300 of them loves cakes. So this 500 is the population number, right? And 300 is the people inside the population who loves cakes. So the population mean, which has the sign mu, is 300 over 500, which simply translates to 0.6. Okay, so calculating population mean should be straight and simple. So here's the formula. Population mean is sum of x divided by n, which is the number of samples, and not samples, numbers of values in the population, right? Second, we have sample mean. So this is basically the same as population mean, but with a sample. So see, sampled values divided by total number of sampled values. So for example one, we have 5 housing complex which has 500 people, and 300 of them loves cakes. So say out of 300 of who loves cakes in complex XY, 20 loves tiramisu. So this 300 is already a sample inside of population, right? So the population is 500, but the 300 itself is a sample of people who loves cakes. So out of the sample of 300, we have 20 who love tiramisu. So the sample mean, or X with a bar on top of it, of people who love tiramisu is 20 per 300, which is 2 per 30. Okay, so this is the properties of arithmetic mean. Every set of interval or ratio level data has a mean. All right, this should be obvious because, the distance between numbers are constant and meaningful. So they should have a mean, but this shouldn't come on the test. So just memorize it. All the values are included in computing mean. Of course, we don't want to leave any value behind, and the mean is unique. It's unique to a sample or it's unique to a population, right? And the sum of the deviations of each value from the mean is 0. So sum of x minus this should be mean, or sum of x is a value, right? Minus the mean, this should be 0. Well, it might be close to 0. So 0.0000005, for example, that's 0, right? And this weighted mean. I don't know why the symbols are messed up on my module, but bear with me. So weighted mean is like this. It's mean but weighted. Special case of the arithmetic mean, it occurs when there are several observations of the same value. So this is very, very, very frequent during in the case of group data. So for example, we have 20 x 25, and the frequency is 10. Right, so this is considered 10 of the same values, right? 20 to 25 has frequency of 10. So how are we going to count the mean if they're all the same values, and we can't be certain or put like a finger on a certain value for this 10 frequency? We use weighted mean. So how we're going to do it should be taught later. So right, so this is just how you do weighted mean. So the weight times the x plus weight again times the x again, blah 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 blah. It goes on and on and on and on. right? So this is the median. It's the midpoint of all the values. For example, 1, 2, 3. It has to be ordered, okay? So if, for example, in the test, there's like this set of data, it's jumbled, and 4, 5. For example, this, you have to arrange it from 1 to 13. You have to arrange it from 1 to 13. You know, from smallest to largest or ascending. And from there on, you can count the median. So the total number of n here is 10. So the median should be the sum of n number 5 plus n number 6 divided by 2. So this is the case for even numbers, but for odd numbers, for example, there's 9. You just take, for example, there's 9 values, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So for this example, you can just take like the middle value because it's clear. It's the fifth number. So the formula is n plus 1 divided by 2. This is your median number. Median n, all right? This is not the median, but the median n. So you count the n up to that median number, a median n, and you pick the data from there. But for even numbers, you have to do averaging again. So relative positions of mean, median, and mode. Symmetric, zero skewness. So when a graph looks like this, it means all mean, median, and mode has the same value. So in this case, it's 20. If it's skewed to the right, for example, it's positively skewed or skewed. I don't know. If it's positively skewed, it should look like this. The top should be on the left part, and the right part, it should be forming a slope. Well, not a slope. Well, it's a slope. It kind of is a slope. So the mode or the I forgot to explain about the mode. I'm very sorry. Mode is the value of the observation that appears most frequently. So out of this data, for example, 1, 2, 3, this one, the mode should be number 1, right? It appears 2 times. So that's the mode. So this is a positively skewed distribution, and this is a negatively one, negatively skewed one. The top of the, or not the top, the peak should be on the right side. So this is negatively skewed, and this is positively skewed. And this is the geometric mean. So how should we find the geometric mean? So the formula is right here. GM equals to the square root of all the products of the values inside of the set of data. Like you have to times it all with each other. And it's not a square root, okay? It's the root of n. So the number of data. It's useful in finding the average change of percentage, ratios, indexes, or growth rates over time. So yeah, rate of increase over time. It should be quite easy. It's the value at end of a period divided by value at the start of period, rooted by n minus 1. Right? Here you can find the rate of increase. So memorize this. This is very important. I think this should come out in the test. So this and this comes out a lot in the test. So this is the measure of dispersion. This is the range. Range is the largest value minus smallest value. This is quite easy. And mean deviation is the arithmetic mean of the absolute values of deviations from the arithmetic means. Okay, so how you do it is you find x. If you have already found the mean is x with a bar on it. So the data minus the mean divided by n. Okay. This is how to find one of the datas, or not the datas, one of the data to find the mean deviation. And to find the mean deviation itself, you have to sum this. Just sum the top. Okay. The sum of x minus x bar. So for example, there's a set of data 1, 2, 3, 4, 5. All right. This is 3. The mean should be 1 plus 2, which is 3 plus 3, so 15. divided by 5, this is 3. So how do we find the sum of x minus x bar? Right, wait a minute. All right, so sorry for the pause. So how do we find the sum of x minus x bar? This should be simple. So 1 minus 3, 3 being the mean, right? Plus 2 minus 3, plus 3 minus 3, plus 4 minus 3, plus 5 minus 3, okay? So this should be simple. And then to find the MD, just divided this all by 5 because there's 5 data here, right? That should be simple. Population variance. This is a variation of mean deviation, if you can see. So the symbol is sigma square. Remember, there's a square. And for the population standard deviation, just root it, just square root it, right? Because population standard deviation itself is the square root of population variance, okay? The symbol is just sigma. And remember that the symbol for variance is sigma square. So yeah, that should be simple, how to turn sigma square into sigma. X is the value of an observation in the population. So X I have explained above. And mu is the arithmetic mean of the population. And remember, this is just for population, okay? We haven't talked about the sample once. And n is the number of observations. For sample variance, this should be quite similar, but please remember you have to subtract n by 1. This is the only difference between population variance formula and sample variance formula. You have to subtract n by 1. So for example, on the data above, all right, there's 5, n equals to 5, right? So, but if you want to make the sample variance of that, it's n minus 1, so 4. Okay. Sample standard deviation, yeah, just the square root of this. So number 10, Sherbert theorem. This is one of the most used one during the test. It's also quite easy, so good for you all. For any set of observations, the proportion of the values that lie between k standard deviation of the mean is at least 1 minus k2, where k divided by 1 divided by k2. I'm sorry, where k is any constant greater than 1. Okay. Sherbert theorem states that 1 minus 1 divided by k2 proportion of the values are within mu plus minus k sigma. So what is that? We're going to discuss that later during the problems. So it's the empirical rule. For some bell-shaped frequency distribution, 68% will lie within plus 1 and minus 1 standard deviation of the mean. So yeah, and about 95% of observations will lie within plus 2 and minus 2 of the SD of the mean. And all of it lies within, practically all, okay? There's still 0.3% left out. Within plus and minus 3 standard deviation of the mean. So remember this, it'll make your life easier, trust me. This is the arithmetic mean of group data. So the formula is x bar equals to sum of frequency times midpoint divided by n. Right, so this is the explanation of the thing I've explained earlier for group data, the 20x25 one, right? So of course, x bar is the mean, sample mean. M is midpoint. So for example, 20 x25. So how are you going to count the midpoint of this? That's so easy. 25 plus 20 divided by 2, that's 22.5. So this is the midpoint. Frequency in each class, of course, as I've mentioned earlier, and Fm is just F times M, okay? And sum of F times M divided by N, which is the total number of frequencies. And standard deviation of group data, it should be simple. Again, just the square root of sum of frequency times, in brackets, midpoint minus the mean, or things you have searched in here or calculated there. Squared, remember the square, divided by total number of observations minus 1, and then you square root it, right? That should be the standard deviation of group data. So problem 3.1, Gabby receives $1,750 a month, but she receives 6% increase in his salary this month, 12% increase next month, 18% increase, and 80% increase the month after. And you have to calculate the geometric mean and the increase of her total salary. So for this one, you have to find the percentage of increase first. So the geometric mean, oh no, you don't have to find that first. So you can't directly find the geometric mean, my bad. Right, so how do you find the geometric mean itself? Is using the aforementioned formula. It's 1 plus 6% times 1 plus 12% plus 1 plus 18%, or not, times, right? And then cube root, because the n is 3, right? And then u minus 1. So you get 11.89%. This should be using this formula, right? This one is used. And then you have to find the geometric mean, right? You are told to find the geometric mean. Not geometric mean, my bad. Increase of her salary. My bad. Right, so how to find it? 1750 times 6%. Where do you get 1750? It's Gabby's base salary, 1750 times 6%. So that's 105, and then plus 105 by the base salary, which is 1855. And you do that again for the next percentages and the next percentages and the next percentages. And you get a total increase of $701.568. Right. But you can also do this, which is just, multiplying it by the geometric mean. So you get this, and then you find it 3 times. So this is basically the same way of doing things as the previous table, but you use all the same percentages so you don't confuse yourself. If you can see, the increase of our salary is quite similar if you find using geometric mean or the given percentages. I think the way which you should do the question, right? The way in which you should approach the question will be written during the test, so don't worry about this. So problem 3.2, moving on. The Fox company surveyed randomly sampled. So this is directly a sample, right? Not a population. It should know that directly. And the survey obtained the ages of these managers. So this is a group data, the one that I have mentioned before. So calculate range, mean, variance, and standard deviation. So for range, this should be quite easy, which is maximum value minus minimum value. So the maximum value here is 55, and minimum value here is 25, so 30, right? Oh, and before you do that, you are advised to make this kind of table so you don't confuse yourself. And because the test for the midterms is technically MCQ, you can do this on Microsoft Excel, which will make your life way easier, right? So this is group data. Frequency is written, and first you have to find the midpoint, right here, because you can't work with group data before finding midpoint. And then just find FM, which is multiplying frequency with midpoint. You find these sets of values, and then midpoint minus a mean. No, before you find that, you have to find the mean, of course, right? Which is the sum of FM divided by N, and N is 50, as you have found here, and FM sum is 1845. So 1845 divided by 50 is 36.5. And hence you can find M minus X bar, which is M minus mean, midpoint minus mean. So for example, for the first data, it's 27.5 minus 36.9. So minus 9.4, right? Negative 9.4. And you do it again for the next set of data. And then you have to find variance, right? And to find variance, you have to find this, the sum of the square of midpoint minus mean. So before you do that, you have to square this. And then frequency times this. So this. So the frequency times bracket midpoint minus mean squared is this. And then you sum it again. And for variance, that's very easy. Just use this sum. And then you divide it by n-1. Why n-1? Because this is a sample, right? Don't forget that. Right, so 2232 divided by 49, it gives you a variance of 45.55. And to find the SD, that's very easy. Just, square root 45.55, and then you get 6.75. Right, that should be straightforward and easy. Okay, so Lavender School selected a random sample of 20 students. And this is a sample. Again, it's written in the question. So be meticulous on that. Extra meticulous because, it's MCQ. So if the data is wrong, well, the answer is going to be wrong. Okay, it's not essay. And this is the grade that the students receive this term. From the BF data, calculate range, mode, mean, arithmetic mean, median, variance, SD, and skewness. So how are we going to calculate skewness? I don't think it was written before. So, okay, we're going to see now. So range should be easy. Just, take the highest data, the data which has the highest value, right? Sorry. And then you subtract it with the data that has the lowest value, which is 66, and you get the range. The range is 66, right? And then mean, just have to add everything, sum everything, and then divide by 20, you get a mean of 64.3. So this is the arithmetic mean. What is arithmetic mean? It's the one I've mentioned before. The sum of arithmetic mean should be 0. So arithmetic mean itself is value minus mean plus value minus mean plus value minus mean. You repeat it until you account for all of the data, and then you sum it, and you should get 0. If you didn't get 0, it means your mean is wrong or there's missing value in your formula. In your formula. A median, it should be easy. So we have 20 data. So median is it should be the 10th value and the 11th value plus divided by 2. So 64 plus 65 divided by 2, 64.5, right? That should be easy. And for variance, you just have to take the sum of value not divided minus mean, and then you square it. So and then you sum it. Divided by 20 minus 1 because it's a sample. So you get 294.43. And to find the SD, just square root that value, and then you get 19.86. And skewness is mean minus median minus mode. All right, this is the formula. All right, so remember this formula too. If it pops out suddenly during exam, that is mean minus median minus mode. Okay. And then you get negative 70.2. So this is negatively skewed as shown by this negative symbol. Right, so problem 3.4, last one. By using the Chebyshev's theorem, at least what percent of any observations will be within 2.5 SDs of the mean? All right, so this should be easy. The formula of Chebyshev's is this: 1 minus 1 divided by k square. It's not k2, my bad. I forgot before. It's k square. So what is k? K is the SD within the SD written in the question, basically. So it is said in the question that should find what the percentage of observations that you will find within 2.5 SDs of the mean. So k is 2.5, so just count by you count using the Chebyshev's theorem. Chebyshev's theorem, 1 minus 1 per 2.5 square, you get 84%. So there are 84% of any sets of observations that will be within 2.5 SDs of the mean, right? So I guess that's it for today. Thank you for paying attention. Don't forget again to fill in your attendance. There's 2 types, right? In the beginning of class and when class finish. So thank you for your attention. This is all for today. I'm sorry for any mistakes that I've made. See you all next week.